Hello. Time for the walkthrough for the part 2 of our recent KA2 assessment. This dealt with the higher topics. Now, as we go through, here's our start. And nice easy start. First off, we come up with simultaneous equations. Now, with these, we've got the x and the y on there, and we're saying that 2 lots of x plus 5 lots of y equal 18. So we can't solve these in the same way as we would normally. But they give us more information there. They tell us 2x plus y equals 6. So what we can do is we can take that away from that. And that'll basically 2x take away 2x. They cancel out. So we've got basically we've removed the x's from what we've got there. So then we have 5y take away y. So we end up with 4y. And then of course 18 take away 6 gives us 12. So we've now got 4 times something gives us 12. So when we divide that by 4, we get y equals 3. So we've got our first identity. We've got our first and part of the answer there. So y equals 3. And I put that in there now so I know I don't get them the wrong way round. Because if I get them the wrong way around, I will lose a mark. Okay. Now, because we now know what the value of y is, we can substitute it into there. And that means we can then work out either of these, okay? Now I'm going to do I'll do this one because it's the easiest one. I'm going to change the colour for that one. So we've now got 2x plus y is equal to 6. So we know that's 2 times x plus 3 to give us 6, okay? So I'll take away the 3 on both sides. I'm left with 2 lots of x is now equal to 3. And of course it's 2 times something, so I'm going to divide by 2. So x is going to give me 1.5. And there's my second part, 1.5. Okay. Question 2. What we're looking at there, we need the value of x, where x is an integer or integer. And basically what that means is a whole number. So something that's divided by 9 is greater than that, but less than that. Okay. So if I look at this, so basically to get that, I know I need to times both of these by 9. So I can do 1.07 times 9, and I can do 1.17 times 9. And as I go through there, I got 9 times 7 is going to give me 63. 9 times 0, that's obviously 0 plus the 6. And then 9 times 1 gives me 9. And for this one, I've got 9 times 7, again 63. They're nice with the numbers this time. 9 times 1, it gives us 9 plus the 6, we get 15. And 9 times 1 gives us 9 plus the 1. So we've now got 10.53. Okay? And we know that x is greater than this, but less than this, and it has to be an integer, a whole number. So it has to be 10. And that's our whole number, because that's the whole number between those two decimals. Question 3 caused a few issues, because people saw, if they weren't too sure, they saw the range, so we did 33 take away 2 because that was our complete range. And I love it when people try even though they're not too sure, so keep doing that in future. It didn't work this time, but let's see why. Okay. And the reason is because this is to do with something we call box plots. Okay. So when we deal with box plots, we've got our first 2 there. I'm going to draw it above because I've got a nice space there. So that's my lowest. So that is the lowest, and that's the highest. Okay. Now, in the middle, right slap bang in the middle, we've got 14. Okay. So we'll put that there. So we've used up this. We've used up that. Okay. But this is the main thing, because this is the middle. Either side, I've now got 1, 2, 3, 4, 5 numbers either side. And slap bang in the middle of that is 10. And here we have got 26. And this is how it ends up as. Okay, and this is our box plot. So these are the quartiles. So this is the overall range, but these are the quartiles. So the interquartile range is the highest, take away the lowest of the interquartiles. So we've got 26, take away 10, which of course gives us 16. So it didn't mention box plots, but that was the best way to work through it. Moving on, question 11. So the translation vector. Now translation vector, they are always shown in the format of x and then y, and of course it's positive, negative, and positive and negative. So because it's a translation, the shape is just being moved from one place to the other. Pick a corner. In this case, I've picked the top right, and we've gone across 1, 2, 3, 4, 5, 6 across. So that means a positive 6 on the x-axis. And then from there, to get down to this same corner, we've gone down 1, 2. So we've moved down 2 on the y, so that's minus 2. Now, what we've got for the next part is to describe a rotation. I'm just going to grab some tracing paper, just so I can demonstrate what we're talking about here. Now the sneaky thing is here, because it's a square, the rotation itself is not immediately as clear. So we've got to turn it, because we've moved it to get to there, but we need to turn it. And to turn it, well, if I put it at 0, 0 at the origin and I turn it, it misses, doesn't it? Okay. So I'm going to come back and I'm going to come across 1 to there. And if I turn there, it goes exactly to where it needs to be. Okay, so from there to there. So that is my center of rotation. So the first one we could have, we've rotated 90 degrees clockwise around, and our point was it was minus 1, 0, and that's our rotation for that one. However, there is another one as well, because we can actually do it. If we do it from here, I bring it down, I can turn it 180 degrees and it ends up in the same place. And this one is a different point. So we can also say rotated 180 degrees. Now we don't need a direction because it's 180 degrees. Either direction will get us to there, but we still need a center. And our center in this case is 0, 3. And that's what they'd be after for that one. Okay, either or. Question 12. It was a ratio question. And they're sharing some money in the ratio of 8 to 5. And the automatic thing is when you see share the ratio, you think, well, I add those, I'm going to divide the amount by that. But in this case, the only information we've got is that Oscar's got £27 more than Nikita. So I'm going to show it basic. 8 to 5. So Oscar and Nikita. And if I do it this way, tell you what, I'll make it one big block. Because 8 to 5. Now Oscar's got 8 parts and Nikita has only got 5, so I'm going to knock off 3 of that one. So you can see the difference we have there. Okay, basically Nikita's getting 3 blocks less, and that means Oscar's getting 3 blocks more, and that 27 is shared between the 3 blocks. So 27 divided by 3 gives us 9, and that tells me that each one of those is going to be 9. So we've got 8 lots of 9. Oscar gets £72 and Nikita's got 5 lots of 9, so she gets £45. When we add them together, we get £117. And that is the answer because it says how much do they have altogether? 117. Now, question 13. What we've got here, so C and D are consecutive cube numbers, and in the middle we've got 4.5 cubed. Now, we're not going to be expected to work out 4.5 cubed, even though I'm sure some of you probably could. But we know that this is greater than C but less than D. So what we can do is we can just work with our whole numbers. Now, we've got 4.5, so the next one, it's greater than 4, stay with the whole numbers. And 4 cubed gives us 64. And here we go up because it's greater than, so the next whole number would be 5, and 5 cubed is 125. And we need, basically we've got the difference between those because it says work out the value of D minus C. So that's this, take away this, it's the range. So 125, take away 64, and that leaves me with 61. Question 13, and we're on to graphs, and of course we're used to straight line graphs, linear graphs, all that kind of thing, but this, it's to the power of something, okay, in this case 2 to the power of x. So this is going to be a curved graph, so we're looking at quadratic graphs. So y is equal to 2 times the power of x. So in this case, I never start with the negatives, okay? But we are going to come back to that. Always start with the next. 0 is already done for us, okay? Now, it's a sneaky one, that one as well, because that brings in the fourth index law. Y is equal to 2 times the power of x. And if the power of 0, so 2 to the power of 0 is 1, because anything to the power of 0 is 1. Then we've got 2 to the power of 1. Now that's just 2. And then of course here we've got 2 to the power of 3, and that is 2 cubed, so we have 8. And then here we will have, that will give us 2 to the power of negative 1. Now we know that 2 to the power of 1 is 2, but because it's a negative we use the reciprocal. So that would be the same as 1/2. Now it is 1/2, but I'm going to write it as 0.5. So I've got 1/2 or 0.5 there. Onto the graph. So I've got my 2 marks for this. I'm going to do the graph now. So here I've got to do -1 and then -1/2. So we are going to go there for the first one. Then I've got 0, 1. So 0 on there. I've got 1 there. Then I've got 1, 2. Then now I've got 2, 4. And then a 3, 8. Okay. And what we've got here, well, we can see we've got our line there. Sorry, I've done that, but I've done that in the wrong place, haven't I? That is -1, but it's 0.5, a positive 0.5, not a negative 0.5, so that should be there, okay? Disregard that for a minute. I was looking at that all the way through that question. You could hear the hesitation because I knew I'd made a mistake. Easily done. And what we see there is we don't have a straight line. What we have is a curve, okay? And that's what makes it that quadratic graph. Now, 2 marks for the graph, so you get 1 for the plots and then 1 for the line. Now I made a mistake there, and that would have cost me. But if the mistake was made here, and then we plotted the graph correctly according to our mistake here, we could still get the 2 marks. Because this is the marks for this are about calculating the other coordinate, And the marks for this are about plotting the graph according to your figures. Okay, so you can, even if you're not 100% sure that they are right, do the graph according to it, because you can still gain marks. 15, and we're into the wonderful world of circle theorems. And the most of it, for the first part, was actually a little bit easier than it looked. So we've got A, C and D are points on a circle, and the diameter is AC. So this is the diameter. ABC, so the ABC, this triangle is an isosceles with AC equal to BC. So that means AC is equal to BC. Isosceles triangle, so that means if those two sides are equal, these two angles are equal. So that means that's going to be 20 degrees as well. So we can do 20 plus 20 gives us 40. Take it away from 180 because angles in a triangle add up to 180. So we've now got 140 degrees here. So far so good. So basically I disregarded all of that and I worked out my triangle. And now I can disregard the triangle, the main part certainly, this, the outside. What I'm interested in is this, because I've now got angles on a straight line, which add up to 180. So that means that is 40. So when it comes to this triangle, to work out x, we need the other two. And on this one, you're not going to work out, because this isn't an isosceles triangle, you're not going to work out this one. It's knowledge. And on part of circle theorems, when you've got 2 points from, when we go from either end of the diameter, where they meet is always going to be 90 degrees. So we know that one is now 90 degrees, and I'm going to write 90 in so I know I'm not going to make a mistake and forget to include it. 90 plus 40 is going to give me 130, and I take that away from 180, and that leaves me with 50 degrees. And that is there. That is my answer. And I'm not going to forget to put it down on the line, but I always like to show them on there. Helps you keep track of what you're doing. Okay? And that's 50 degrees. So circle theorems for that one. Question 16 is all about set notation. And for these, well, there's many ways we can do it. And what I'm going to do is when I post these up, the work on Teams, I'm going to include the picture of the set notations. And that will make our lives easy. We can look at those. Now, as they stand, so this one, we've got A union B. So that is all of A and all of B, including the centre. And then we've got, so this should be A union B. So A complement A union B. And that one, we go for our third. That one will drop down to here. And then this is basically everything but the union of A and B. So this one comes up to here. And this last one is not used. That's the bobby in the pack. Now, 17, probability tree. So we've worked with these a little bit before, but this is fractional. And this is where it becomes a little bit more interesting. First thing here, if it's a 1 in 6 chance of being on time when it's raining, sorry, 1 in 6 chance of it raining, that means there's a 5 in 6 chance of it not raining. Okay. And a bus on time, 9 in 13 chance of it not being on time, which means it's only a 4 in 13 chance. And what it says here, the probability that the bus is on time is halved when it is raining. So what we have actually is 4/13. Well, if that's been halved to get to 4, that means the probability of being on time when it's not is 8 out of 13. And that means our last one On the other side, the flip side, that will be 5 over 13. Okay. So now we want, part B, the probability that that at 1 p.m. it is raining and the bus is not on time. So raining is 1 in 6. And we want, so we said the bus is not on time. So that's yes to raining and no to being on time. So that gives us 9/13 there. I'm putting an equal sign when I should be putting a multiply. There we go. Now the equals. So 1 times 9, and that gives me 9. And 6 times 13, I'm sure you're all screaming it out from the top of your heads. We've got 78. And we can simplify that down. And that simplifies down to 3 out of 26. Now, it didn't ask us to simplify, so either one of those will get us the marks. And what we're after is obviously picking out the right probabilities to use and then the answer for our 2 marks. Question 18. Now this is particularly nasty. Okay? And it relies on you knowing your trigonometric ratios. And I do have some cards here with them on, if I can find it. Bear with me one moment. In fact, I don't think they're all in horrible order. So I will post up put a picture of the slide in the Teams folder when I've done this one. Okay. So we've got the sine of 30 times the cosine of 45 degrees divided by the tan of 60. So what we end up with, sine of 30 is 1/2. The cosine of 45, and we've got square root of 2 over 2. And then the tan of 60 gives us the square root of 3. And already, I know, people who are switching off go, wow, don't know that. This is basically the knowledge of what those values are. And then when we calculate that, we will get, and basically, I'm not going to go through the whole calculation. What we end up with is square root of 6 over 12. And we've got, so they're saying A and B are integers, so these are whole numbers. That's what they wanted there. Kind of skipped over that one a little bit. It's one of those you would need to do a lot of work in with the actual ratios and how they're calculated. So it's more than I can explain just on one question. Okay. So now we've got the value of 9 over 16 to a negative 3 over 2. And when they're talking about these, what we have there, we have a cube, but we also have a square root when they're talking about negatives. So what we end up with here is going to be 64 over 27. And we can, or if you wanted to change it, we would end up with 2 and 10 over 27. Again, the process, we'll get more into index laws. We're going to be covering index laws in class in the foundation. We will be putting an extra session on to help with those for the higher, and we will discuss all the higher stuff once we've been through these papers. And we've got square root of 125 is equal to 5 to the power of something. And what catches people is they see the 125 and they go, well that's 5 cubed, so 5 must be to the power of 3. But it's the square root of this, square root of 125, which is equal to the power of that. And what it ends up as, and we can have that power as being either 1.5 or 3 over 2. And again, that the calculation for that we will go through more in depth in the class. Okay. Now I know the last few questions were fairly skimmed over, but I hope it's still been a good help for you. And for those who've done well on this paper, we're hoping to offer, we will sort out a way for you to study the higher, and for those who haven't, well, we know we can concentrate on our foundation. No shame in that. See you soon.